Hello, Miss Newen. This is my video for the second question of the Unit 5 Limits project. So it's a question about the piecewise function. So piecewise function is basically a function made up. It basically has multiple other functions inside of it. So this is what my piecewise function looks like. There's two junction points. There's one right here at x equals 4. It's a smooth transition. Now over here, you'll notice that there's a gap. And at this junction point where these two points of my function are supposed to connect, there is a discontinuity. And it obviously, if you watch the first video, it's pretty easy. I mean, you will probably know by obviously, but it's a jump discontinuity. It's pretty obvious. So the two junction points is with my parabolic function and my linear function, and then the other one is between my absolute function and my linear function inside the piecewise function. So the work I've done here, I found the limits of each junction point. So the first one, as I mentioned over here, right here, this one, I found the limits approaching 4, because that is the first junction point. So approaching it from the left side, and while it's approaching it from the left side, I use the first function, the parabola, or the quadratic, sorry, because that is a function that approaches 4 from the left side of the function as a whole. So as a whole, the parabola approaches it from the left side. So that's why I use that, and I got a value of 8. And from the right side, what approaches 4 from the right side of the function as a whole is the linear. So for the right side, or for the limit of the right side, when x is approaching 4 from the right side, I used the linear function equation. So I also got 8. So as x is approaching 4 from the right side, I also got 8. So because obviously, these two limits, the limit exists because the left side approaching 4 from the left side is equal to approaching from the right side. So this limit does in fact exist. And obviously from the graph, it's pretty easy to tell. It's smooth. There's no, if you zoom in, there's no gap or anything. For the second point, visually you can already tell the second junction point, or where it's supposed to connect. There's a big space here. Oh, sorry. There's a big space here. So consider when x is approaching 7. So that is the point when it connects. So when it's approaching it from the left side, when x is approaching 7 from the left side, in this case, it is the linear from the left side. So I use the linear equation, 2x, and I got 14. Now when it is approaching from the right side, this is when this is the absolute value function. So I used that equation for the right side, and I got two different values. So when it's approaching from the left side, y is at 14, but when it's approaching it from the right side, it's hitting 35. So because the two sides don't match up, this limit does not exist. And obviously, like I mentioned before, it's pretty easy to tell that there's a big gap here, and you can obviously tell there's no asymptote, there's no dot, so it has to be a jump discontinuity. Okay, thank you for listening.